So students, these reduction formulae are used to integrate, like you cannot integrate cos raised to power n dx. Okay, so you try to write it in the lower degree terms. So write in lower powers. So some kind of recursions formulae. Okay, so first of all, let us see if you have an integration of the type x raised to power n e raised to power ax. Okay, e raised to power ax dx. So how to find the reduction formula, how to express this in a lower degree term. So some these are done using either integration by parts or method of connecting integrals. So here I will write in as x raised to power n e raised to power ax dx. Okay, and now I integrate it using parts. So first function as it is, integral of second e raised to power ax upon a minus integral of derivative of first and integral of second. Okay, so what do you get here? You get x raised to power n e raised to power ax upon a minus n upon a, and the remaining integral is, if you can see, it is in minus 1. So this formula is the reduction or recursive formula for in. Okay, similarly you have reduction formula for log integrals x raised to power m log x raised to power n dx. Okay, so here you have two powers, one is m, other is n, two indices. So of course our integral will depend upon both. So I will write it as imn, which is integral x raised to power m log x raised to power n dx. Okay, so let us integrate it using parts. So log x, first function as it is, integral of second which is going to be x raised to power m plus 1 upon m plus 1 minus differential of first. So differential of first, you know, n log x raised to power n minus 1 into 1 by x, and the remaining part is as it is, m plus 1 upon m plus 1 dx. Okay, so imn will become x raised to power m plus 1 log x raised to power n upon m plus 1. So of course you would need to remember this formula, minus, now n upon m plus 1 can be taken outside, and you will get x raised to power m log x raised to power n minus 1. So you will get im as it is, n minus 1. Okay, so this is the reduction formula for log integrals. And yeah, now let me give you an example how to use such integrals. first of all, let me tell you another formulae for which are of more use. For example, reduction formula for integral sine nx. Now many of the students commit the mistake, like you can easily differentiate sine nx, okay, sine raised to power nx, it is n sine n minus 1x into cos x, okay, but you cannot do sine n plus 1x upon n plus 1 while doing integral, okay. That is the usual mistake many of the students do. Please be careful, okay. These sine and cos, in fact अगर ਤੁਸੀਂ sin square x dx ਵੀ ਤੁਸੀਂ ਕੈਲਕੂਲੇਟ ਕਰਨਾ ਹੋਵੇ ਤਾਂ ਵੀ ਤੁਹਾਨੂੰ ਉਸ ਨੂੰ 1 minus cos 2x by 2 ਚੇਂਜ ਕਰਨਾ ਪੈਂਦਾ ਹੈ, ਓਕੇ. ਸੋ what would you do if you have in general sin raised to power nx, ਤਾਂ ਇਸ ਨੂੰ ਆਪਾਂ in ਹੀ ਲਿਖ ਲੈਂਦੇ. ਸੋ in ਇਸ ਨੂੰ ਲਿਖਦੇ ਹਾਂ sin nx dx, ਓਕੇ. इंटीग्रेशन बाय पार्ट्स लगाने ਲਈ मैं इसनों दो चीज़ां कन्वर्ट कर देना n minus 1 into sin x dx, okay. So let us apply now. So first function as it is, integral of second sin x the integral cos x minus cos x minus integral differential of first. So differential of first will be sin x raised to power n minus 2, and derivative of sin x is cos x. Also I have the integral of sin x, which is minus cos x dx, okay. So this becomes minus of sin n minus 1 x. So if you get confused, I will write it as power n minus 1 cos x minus integral, let me bring this n minus 1 outside, so plus n minus 1, this negative sign, and n minus 1. Now what will you get? Sin x raised to power n minus 2 and cos square x. So I will change cos square x into 1 minus sin square x dx, okay. So what will you get? You will get minus sin x raised to power n minus 1 cos x plus n minus 1. So open the bracket, the first one will be sin x raised to power n minus 2, so I will write it as I n minus 2, and second one will be negative of n minus 1 in, okay. So bring that in this side, so 1 plus n plus 1 n minus 1, so it is n times in, okay. It is equal to n minus 1 times in minus 2 minus of sin x raised to power n minus 1 cos x. So in becomes n minus 1 upon n in minus 2. So directly you are going 2 degrees lower, okay. Sin x raised to power n minus 1 cos x. So अगर तुसी for example sin raised to power 6x कैलकुलेट करना होए तो sin raised to power 6x ਨੂੰ ਪਹਿਲਾਂ sin raised to power 4x ਦੇ ਵਿੱਚ ਲਿਖ ਲਓ, ਫਿਰ sin 4x ਨੂੰ sin square x ਦੇ ਵਿੱਚ ਲਿਖ ਲਓ, sin square ਨੂੰ ਤੁਸੀਂ 1 minus cos 2x ਕਰਕੇ ਤੁਸੀਂ ਇੰਟੀਗ੍ਰੇਟ ਕਰ ਸਕਦੇ ਹੋ, okay. So similarly we have reduction formulae for cos nx. ਇਹਨਾਂ ਦੇ ਪ੍ਰੂਵ ਕਰ ਲੈਣਾ ਤੁਸੀਂ. For cos nx, integral cos nx, so which is equal to, if I am writing it as in, so it becomes in, which is integral of cos nx dx. So it will be a similar one, no doubt. it is n minus 1 upon n in minus 2. So in fact of minus you have plus, and sin x is changed to cos x, and cos x is changed to sin x. Okay, so if you remember the reduction formula for sin x, it is easy to remember for cos x, and no doubt you will also have the reduction formula for tan x. Integral of tan nx dx. So ਇਹਨੂੰ ਕਿਦਾਂ ਲਿਖਾਂਗੇ ਆਪਾਂ, tan nx dx is equal to our in. So that is going to be, now this can be, it is tan x raised to power n minus 1 upon n minus 1 minus I n minus 2. Okay, so similarly you have a reduction formula for cot nx, secant nx, cosecant nx, and alright. So using these reduction formulae, try to solve examples as well as exercises. Now next is the reduction formula. It was just earlier sin raised to power nx, sin raised to power n x dx. Now what would happen if you have some x is also multiplied to that? Okay, x sin n x dx. So what will you do here? So this is in. So of course we have to integrate by parts. What will be our first integral? Our first integral will be this one. Okay, and second integral will be sin x dx. Now do the integration by parts, and after some steps you will get. So do the integration by parts, and what will you do here? You will get n in is, so of course it will be again a similar kind, n minus 1 in minus 2 minus x sin n minus 1x cos x. So far it is similar to this. Okay, x is there extra, plus there is another term sin nx upon n square. Okay, upon n. So in is n minus 1 upon n in minus 2 minus x upon n sin n minus 1x cos x plus sin of nx upon n square. Okay, n minus 2. So this is the formula for integral of x sin nx, and no doubt if you have in integral of x cos nx dx, then you have the reduction formula as in is equal to n minus 1 upon n in minus 2. Now you can easily guess, plus x upon n cos n minus 1x sin x plus cos nx upon n square. Okay, so this is the formula for x cos raised to power n x dx. And similarly, let us generalize it to more. What will happen if your in is, now imn, so I am generalizing this more. x ਦੀ ਜਗ੍ਹਾ ਅਗਰ ਤੁਹਾਡੇ ਕੋਲ x raised to power m ਹੋਵੇ sin nx dx, okay, then what will you do? Then just take x raised to power m as a first function and this as a second function. Wait, not this one, there is a change here. It is sin nx, okay, sin nx, not power here but sin nx. Power is x raised to power m, okay. Now what will you do? This will be our first function, this will be second function. आइलेट रूल लगा सकते हो तुसी, आइलेट रूल की है ਤੁਹਾਨੂੰ फर्स्ट फंक्शन ਕਿਹੜਾ ਹੋਏਗਾ हमेशा आई मीनस अगर ਉਹਦੇ ਚ इनवर्स फंक्शन है तो इनवर्स फंक्शन हमेशा फर्स्ट फंक्शन होएगा L लॉगरिथमिक, A अल्जेब्राइक यानी कि पॉलिनोमियल, T ट्रिग्नोमेट्रिक लाइक इथे अल्जेब्राइक है x रेज टू पावर m, T trigonometric and E exponential. So exponential is the last क्योंकि exponential ਦਾ इंटीग्रल करना हमेशा ईजी ਹੁੰਦਾ है, इस ਲਈ exponential ਨੂੰ ਕਦੇ ਵੀ ਆਪਾਂ फर्स्ट फंक्शन नहीं लेंदे, okay, we always keep it as a second function, okay. So after, again I will not write the whole proof, you can do first function second function integral by parts. What will you get here? Imn will be minus m minus 1 upon 2 upon n square I m minus 2 comma n. So n is as it is, only m, index m is decreasing here, minus x raised to power m cos nx upon n and plus m upon n square x raised to power m minus 1 sin nx, okay, ठीक. So that is the reduction formula for x raised to power m sin nx, and what would be the formula for cos nx dx? So here Imn will be equal to, so की होएगा minus m minus 1 upon n square. So this first term is same, then instead of minus, yes, you have plus x raised to power m upon n, cos दी जगह sin आ जाएगा, बाकी फिर सेम m upon n square x raised to power m minus 1 sin दी जगह cos nx, okay. So there is always a similarity between the formulas of cos and sin, okay. This is what you get. And let me give you few more. So reduction formula for, if your Imn is, now instead of polynomial I am going to trigonometric sin nx dx, okay. So no doubt this is going to be a lengthy procedure to prove this formula, because you have to convert many things, and also you need to write cos raised to power mx in terms of you have to integral sin nx, okay, many times. So there is a chain which will go, and ultimately you will find some repetition of the integral. So that is the step where you get the recurrence formula. So you will get cos raised to power m x cos nx upon m plus n plus m upon m plus n I m minus 1 n minus 1. It has only two terms, but the procedure is lengthy. So Imn is minus cos raised to power mx cos nx upon m plus n, okay, plus m upon m plus n Im minus 1 n minus 1. Similarly, now we will interchange cos and sine. So you will get the formula for, first of all, let us find the formula for cos mx cos nx dx. Okay. So here you will get, after again applying first function and second function, you will get cos mx, so माइनस नहीं आएगा ऊपर वाले फंक्शन का, cos nx की जगह थे sin nx अपॉन m प्लस n प्लस m अपॉन m प्लस n Im minus 1 n minus 1. Okay, so you can see the similarity again, and if you remember the one, you can easily write the other one. And last formula for our today's course is Imn is equal to sin mx cos raised to power nx dx. Okay, so here m is not equal to minus n. This is the condition we have. Both are natural numbers. So if both are natural number, this choice can be redundant. You don't need to write it. Then this is going to be the biggest. Imn is equal to, so remember this, sin m plus 1x cos n plus 1 n minus 1 x upon m plus n plus n minus 1 upon m plus n Im n minus 2. Okay, Im n minus 2. This is what you get. Thick. So there are many questions and examples based on a reduction formulae which I told you, and try to do these exercises. I have covered first 3 exercises of reduction formulae, others are done later. Okay, thank you very much.